Hello, in this presentation, we are going to discuss about Huffman tree, concept of Huffman tree, creating Huffman tree for data encoding. So this is the algorithm for each encoding unit. Uh, Encoding units can be a letter, associative frequency. Suppose, suppose if I take an example, computer, the word computer. C is the letter. The letter C, what is the frequency of letter C in computer word? Only one. Second letter is O. What is the frequency of O in the computer word? Frequency means how many times the letter is appeared in the text. So in a text message, so each letter is considered as the encoding unit. So associative frequency means how many number of times the letter is appeared in the given text. Next, create a binary tree. Binary tree means the parent node will have a maximum two children's, two child nodes. That means a parent node will have a maximum two child nodes. So after constructing the frequency chart, we have to create a binary tree whose children are the encoding units. Encoding units means encoding units are the letters in the given text. And we have to create a binary tree whose children are the encoding units with the smallest frequencies. The frequency of the parent node will be the sum of the frequencies of the childs. So frequency of the uh, parent node will be the sum of the frequency of the child nodes. So we have to repeat this procedure until all the encoding units are in the binary tree. So example, assume that frequencies are, assume that the letter A is appeared 40 times, letter B appeared 20 times, letter C appeared 10 times, letter D appeared for 10 times, letter R appeared for 20 times. So in this frequency information, smallest number or numbers are what? 10 and 10. That means uh, node C and node D. See, consider all these letters as um, leaf nodes. Leaf nodes means termination nodes. So in this example, the smallest numbers are C and D. See, to create a binary tree, we need two child nodes. Suppose if I want to create a binary tree means obviously there will be one parent node minimum. I'm telling. So there will be one parent node and there will be two child nodes. So we have to choose two child nodes. So in this example, in the step number one, the two child nodes are C and D. So connect those. Yes, C is having least frequency and D is also having least frequency 10 and 10 compared to all both C and D having least frequencies. So that C plus D had the frequency information of C and had the frequency information of C and D. So we will get 20. So then in the step number two, Now the letter A is having the frequency of A is 40, frequency of B is 20, and the frequency of C plus D, this will be considered as C plus D. 20 is the value of what? How 20, the value 20 came after adding C and D. So now we call it as C plus D. So the frequency of A is 40, frequency of B is 20, and frequency of C plus D is 20, and the frequency of R is 20. Now again we have to choose two minimum frequencies. So according to the example, now two frequencies are actually we have three options. One is B is also the frequency of B is 20, and the frequency of C plus D is 20, and frequency of R is 20. So we have a three nodes. One is B, and second one is C plus D, and third one is R. So according to our binary tree construction, we need two child nodes. We need two child nodes means either we can connect B and C plus D, or we can connect C plus D and R. Either we can connect B and C plus D. That is one option, and second option is we can also connect C plus D and R. So we can connect either one. We can choose anyone. So yes, in this example, I have connected B and C plus D. So frequency of B is 20, and frequency of C plus D is 20. 20 plus 20, it is 40. Now the frequency of parent node is 40. So in a step number 3, now again we need to choose two child nodes who's having minimum frequency information. Yes, now we have first child node is A. The frequency of A is 40, and now it is referred as B plus C plus D. 40. The now the parent node. See, this is dark black circle. Um, this is what is the value in that 40? How the value 40 came after adding B plus C plus D, right? So now it is completely considered as the B plus C plus D. So now we have three child nodes. One is A, that is 40, and second child node is B plus C plus D, and the third child node is R. The frequency of first child node is 40, and the frequency of second child node is 40. Second child node means that is B plus C plus D, and the frequency of third node is 20. So now we have to choose two child nodes who's having least frequencies. According to the example, uh, the least frequency is 20. That is letter R. So that can be connected to anyone. Anyone means because here we have two options. Either it can be connected with A, or it can be connected with B plus C plus D, because A and B plus C plus D both are having the same frequency, that is 40. Now we see, yes, I have connected with I have connected child node R with B plus C plus D. Now the frequency of parent node is 60. How? Because the frequency of B plus C plus D is 40, and the frequency of R is 20. 20 plus 40, that is 60. Now the frequency of a new parent node is 60. 60 is nothing but that is summation of b plus c plus d plus r. So it will be considered as the b plus c plus d plus r. Now we have only two child nodes, that is 60 and 40. 40 means letter A. Letter A is the frequency of letter A is 40 and the frequency of new parent node is 60. So now we have to connect these two. So connect these two. So now the frequency of new parent node is 100 because the frequency of A is 40, the frequency of previous parent node is 60. 60 plus 40, that is 100. Now this 100 will be considered as the node having 100, that it will be considered as the root node. A, B, C, D, R will be or these will be these are term leaf nodes. A, B, C, D, R are leaf nodes. 100 is the root node. So this is the complete Huffman tree. We have constructed this based on the frequency information. Right? This is called as Huffman tree. We use Huffman tree to encode the data. We have successfully constructed Huffman tree based on the frequency information. Frequency information means how many number of times the letter is appeared in the given text. In this example, the leaf nodes are A, B, C, D, R and the root node is 100. Now we have to encode this. How to encode? Assign 0 to all left branches and value 1 to all right branches. See, all left branches are assigned with value 0 and all right branches are assigned with are associated with value 1. Now we have to encode each letter. So this is the encode data. Now this is the encoding information. The A is encoded as 0. Why? Because for data encoding we have to start the traversing process from the root node, from the root node to uh, leaf node. Take the first leaf node, that is A. Traverse the tree from the root node to leaf node. See, start from the root node. Root node means which is located at the top portion. So traverse from that place to leaf node place. So that is 0. That is 0. Next B is 100. Why it is 100? Because start from the root node, then you need to traverse right side. Yes, right side, right branch is associated with value 1. So value 1. Next, to reach leaf node B, you need to traverse a left in the left side. So the left branch is assigned with value 0. So that is 0. Next, to reach a leaf node B, you need to traverse left side. So that the left branch is assigned with value 0. So to reach leaf node B, so first we have to start the traversing process from the root node. Then we need to traverse right, then left, then again left. That's why it is 100. Then C, to reach leaf node C. Yes, sir. Now we need to start from the root node. Then we need to traverse right side, so that is 1. Next left side, that is 0. Next again right side, so that is 1. Next left side, so that is 0. 1 0 1 0. To reach D, start from the root node. Yes, to reach leaf node D, we need to traverse towards the right side. So 1, next 0, next 1, next 1. So the encoding information of D is 1 0 1 1. Next, to reach leaf node R, yes, we have to start from the root node. Then to reach leaf node R, we need to uh, traverse the tree from the root node, then towards the right side. So 1, next again towards the right side, so that is 1. So encoded information of letter R is just 1 1. So this is data encoding. A is according to this example, A can be encoded as 0, B can be encoded as 100, C can be encoded as 1010, and D can be encoded as 1011, and R can be encoded as 11. So this is the concept of Huffman tree. So thank you for listening this presentation. Take it as assignment. Here I have given one small assignment, that is science. Consider science is the text information. In that how many letters are in the science word? There are 7 letters in the science word. Yes, letter S appeared one time, and the letter C appeared in 2 times, and letter I appeared in 1 time, and letter E appeared appeared in 2 times, and letter N appeared in 1 time. So to take it as assignment and construct the Huffman tree for this data, and write down the encoded information for each letters. Thank you, one and all.